For those of you who don't know me, my name is Colgan. I'm the product manager for the Oracle Optimizer, and joining me on stage today is Jonathan Lewis, who I'm going to let introduce himself. So, Jonathan.
Okay, thank you very much. I think we'll keep this really short. There's the slide. That's about half of my life. Okay, two lines which are important. The top line, independent consultant. Right? Maria works for Oracle. I don't. Which one do you trust more? Bottom line, O1 visa for the USA. I'm actually allowed to work in the USA and be paid for working in the USA, which is why I come to things like this. But I have to warn you, it is a requirement from the American government that I charge extortionate fees for doing so. I nearly charge as much as an Oracle consultant. Now, at that point, I will pass you back to you.
All right.
Who says there's not going to be a bloodbath?
No, I was going to say, so anybody who does follow us on Twitter, you will understand that you are looking at the Irish versus Welsh match today. Man versus woman, Oracle versus consultant, whatever way you want to do it. Yes, I'm supporting Ireland, obviously. So what are we going to cover today? Today's material is not instantly going to make you a consultant that can charge extortionate amounts of money. I apologize for that now. It's also not going to miraculously fix every SQL that you have problems with. What we are hoping to provide to you is two different opinions on 5 topics. Jonathan wants to make sure that you can all do the math. 5 times 2 is 10 tips. See, they can all stay.
Anyone who didn't get that right should leave the room at this point. Okay.
You are going to get 10 tips on these 5 topics from us, hopefully. And within that, it may not be all brand new to you, so I apologize to Connor who gave up his viewers for this if it's not all brand new to you. But hopefully there will be something there that resonates with everybody and you'll be able to take home and help improve the SQL performance in your environments. So we are going to cover 5 tips. The areas that we're going to look at is using the right tools, being able to get the information you need to make an informed decision about how to go about improving query performance. We're going to talk about finding the right sample size, so that's gathering statistics, information in that space. Talking about telling the optimizer everything. As much as we like to think the optimizer is out to get us, it is only as smart as the information that we give it. So we're going to talk a lot about how you can tell the optimizer the right thing. We're going to talk about functions, whether they're your friend or foe, and we'll talk about what the best ways to use functions. And then finally, we'll talk about the topic that I dread the most, but I felt was required if we were doing tips, hints. All right? So let's get this party started. We're going to start with using the right tools. We've got a very simple query here. We are looking for the number of customers we have in a specific zip code. Now there is a bitmap index on the zip code, and we're using a bind variable to pass in the different zip codes. There is a histogram on zip code because there is a skew in this column. A lot of our customers live close to the store, but we do have some out-of-state customers too. So there is a pretty big data skew there, so we did create a histogram. So from this point of view, statistics are reasonably good, or you should assume the statistics are accurate. So I do an explain plan command, and I got a full table scan instead of using the index. Why is that? Why did I get a full table scan and not use the index? Even though there was a bind variable defined, you see it up there at the top of the screen. Explain plan ignores binds. It is not bind aware. It does no bind peeking. It's not able to realize that we passed what value we passed in. And based on that, it comes up with a very strange cardinality estimate. Which column of the plan indicates the cardinality estimate? The rows column of the plan, right? You see that right there. So we got this strange cardinality estimate of over 10,000 rows we returned. Where did that come from? It came from the fact that we weren't able to use the histogram, so we have to go back to the base column statistics. Because we didn't know what value was being passed in by as the bind, we go back to the base table statistics, number of columns, number of distinct values in that column. So I have 20,000 rows in my table, 2 distinct values, the zip code for the store, and another alternative zip code away from the store. That's the map that the formula the optimizer is using. It came up with 10,064.5. 65. The optimizer, well, it's not in fact actually the optimizer, it's the execution plan table doesn't like non-round numbers, so we always round up. Okay? So we round it up to 10,065. That's where the cardinality estimate comes from. If we actually executed the query, and then we looked in our SQL plan at the actual plan that was used for that SQL statement, we will see that we did in fact use the index. Bind peaking occurred, we realized the value we were looking for was not the popular value of the table, and that we should go ahead and use the index. And you'll see the cardinality estimate is really low now because we're using the histogram and it tells us very few rows are being returned, so an index access plan is the best plan. So what I'm trying to say to you is that explain plan as a tool doesn't work very well for SQL statements with binds. Now, if we were to execute that same SQL statement 3 times, so we did explain plan 3 times, and then we executed it 3 times, you will see 4 cursors in the shared pool. 3 of them belong to the explain plan. The reason being is that explain plan forces the hard parse every time and a new cursor to be created. You'll also notice that there was no bind data associated with any of those cursors because explain plan does not peek the binds. It has no idea what bind value is being passed in, so it can't take advantage of the histogram. It has to rely on those base table statistics. The one that I used and I actually executed the query with, they had 3 executions of a single cursor. That cursor is using the index, so you'll see they've got different plan hash values. And you'll see that it also has bind information because we did peek the bind and we used that bind value to help us determine a plan. Now at this point, Connor is definitely thinking he should have gone to the bar. He knows this already, that explain plan doesn't help with binds. Why is she banging on about this and wasting precious moments in the presentation on it? Well, I'm banging on about it because there's a very common tool that is used by a lot of performance experts that you pay big bucks to come on site to your place of business and to help you tune. And that tool that they're using is AutoTrace Explain. Now AutoTrace is a great tool. You get it through SQL+. It allows you to learn a lot of information about what happened during the execution of a SQL statement. AutoTrace only explain runs explain command. That's what it does, which means it's not bind aware, and it means that you may not really be seeing what's going to happen during the execution. Like, okay, fine, so it uses explain, why do I care? Here's why you care. If you issue the statement 3 times using AutoTrace Explain, you don't see 3 different cursors. AutoTrace Explain doesn't mark this cursor in the shared pool as an explain plan command. That cursor is shareable and will be shared by anybody who executes the query in their own session without AutoTrace Explain preceding it, which means they're all going to get the full table scan plan, even though they could have peeked the binds and they could have used the right plan. AutoTrace does not mark those explain plan outputs as non-shareable, which means you could in fact see poor performance in your environment and not even know why it's occurring. Worth the beer, Connor? Not worth the beer. You'll have to tell me afterwards.